All right. So 5.6, day 2. Do we have our packets out? Are we ready to get started? Are we there? Are we awake? Okay, Corey's here. Anyone else here? Okay. All right. So 5.6, day 2, we're going to be graphing linear inequalities in standard form. We have graphed in standard form. It's been a little while, so we might need to review that a little bit. But what we do today is very similar to what we did yesterday. So remember, we had a few steps from yesterday. This is when we were graphing our lines, and then we shaded on one side or the other, and we had to decide if our line was dotted or solid. So same stuff. Step one is still to graph the boundary line. That is just a fancy phrase for graph the line. Oops, sorry. Okay. Then we need to decide if it is a dashed or dotted. I tend to say dotted. I have dash typed though. A dotted or a solid line. Can someone remind me, when do we use a dotted line? What kind of inequality symbols are we going to see? Remember, our inequality symbols, we could have a less than, we could have a less than or equal to, a greater than, or a greater than or equal to. So who can remind us what we use for a dashed line? So the dashed line is kind of like an open circle when we were doing our shading. Like when we had something like this and we would have an open circle, right? And we would shade to the left or the right. When did we use an open circle? Did we use an open circle when it was equal to or not equal to? Do you guys remember? Yeah, when it was not equal to. So for this, a dashed line, Corey, is kind of like that open circle. So we used a dashed line when it's actually not equal to. So we will use our dashed lines for just a basic less than or a greater than. So we use our dashed line if we're dealing with less than symbols or greater than symbols. And then for the solid line, remember, a solid line is like a filled in circle. So then somebody else, use a little process of elimination here. What are we going to use if we're looking at a solid line? Yeah, the or equal to part. And I think I talked to Alex about this yesterday. A kind of a way to remember it is, doesn't the or equals to one, don't they have a little line underneath it? So if they have a little line underneath it, then you use a solid line. So if you see a line, use a solid line. So this would be the less than or equal to or greater than or equal to. All right, then we need to decide if we need to shade above or below. So remember, we sometimes have values that are greater than or equal to, or less than or equal to. Does anyone remember when we would shade above? Would we shade above if we were dealing with values greater than or values less than? What do we think? Sorry, what was that, Corey? So when you think above, do you think more or less if something's above something else? More, yeah. If something's above, you think more. And is more like greater or is more like less? Greater. So if we're dealing with above, we shade above if we're dealing with things that are greater than. So that would be our greater than symbol or our greater than or equal to symbol. So then we shade below. Below means like fewer or less. So we shade below if less than. So that would be our less than or a less than or equal to symbol. Yeah. Is this stuff sounding familiar from yesterday, guys? Yes, no, maybe. Are we awake? We seem awfully sleepy and unawake today. Okay. Okay, thank you, Alex. All right. All right. So today what we're going to do is graph them when they're in standard form. Do you guys remember when we did the cover-up method? Like you would cover up your x to find y, cover up y to find x. We're going to use that same strategy today. Or we can rearrange into y equals mx plus b, but I think you guys tend to do better with the cover-up method. Something to remember if we do rearrange a y equals mx plus b problem, something we need to remember to do is if you divide by a negative, who remembers what you have to do to your inequality symbol if you multiply or divide by a negative number? Yeah, you have to flip it. So you must flip your inequality symbol. But I think we're going to try to stick with cover-up method when we can. All right, so graph the following linear inequalities. You may want to rewrite some of them as y equals mx plus b or use the cover-up method. So I tried to put some basic ones first. We have x plus y is less than or equal to -4. Now, this is not in the same form that we looked at yesterday. This is not in y equals mx plus b form. Could we rearrange it if we wanted to? Sure. Could we do the cover-up method if we wanted to? Sure. I feel like you guys probably like the cover-up method more. Do you guys remember? Did you like the cover-up method? If anyone remembers even. It was a while ago. Okay, let's review. So the cover-up method, that's what we use to find our x-intercept. Okay, that's fair, Corey. So our cover-up method was what we used to find our x-intercept and our y-intercept. So if I want to find my x-intercept, I need to cover up my y. And I don't want you guys to actually scribble it out because you'll need to see it later. But if I want to find my x-intercept, I want to cover up y. So, and you can kind of ignore the inequality symbol, treat it more like an equal sign. But I'm going to have x is less than or equal to -4. That means my x-intercept is the number -4. So what we're going to do on our x-axis is put a dot at -4. Then, if I want to find my y-intercept, what would I cover up? If I cover up my y to find my x, what am I going to cover up if I want to find my y instead? Yeah, cover up the x. So then if I cover up the x, I end up with y is less than or equal to -4 again, right? So then on my y-axis, I'm going to put a dot at -4. Now don't I have two dots? If I have two dots, can I connect them with a line? What do we think? Yes or no? If I have two dots, can I connect them? What did you think, Hayden? Yeah, absolutely. So now we just got to decide, okay, is that line solid or is it dotted? So take a look at your inequality symbol. And you can look up above at your notes. If we have the or equal to underneath, do we use a solid line or a dotted line? Good, Corey. Yes, we use a solid line. So we are going to connect this with a solid line. Good. And then we need to decide if we need to shade above or below. So remember, this is a less than or equal to. So if it's a less than, do you guys think I would shade above the line or below the line? Yes. If it's less than, you shade below. Good. Okay, Highland, I see you there. And yeah, good, Olivia, you'd shade below. Does the finding the dotted or solid and then the shading, does that sound familiar from yesterday? What do we think? Does that sound familiar? Guys, remember, I can't see you, so I need responses. Okay, okay, thank you. All right, so now we're gonna take a look at number 2. Almost the exact same, right? If you take a look, very similar. So now let's look at 2. We have x plus y is less than 5. So let's find our intercepts. So if I want to find my x-intercept, Aaron, what do I need to cover up to find my x-intercept? Cover up y. And I'm going to just have x is less than 5. So Aaron, where can I put a dot on my x-axis? On 5. So go to your x-axis, put a dot on 5. Good. Asia, what do I need to cover up to find my y-axis? Yep, cover up the x. Good. So that'll give me y is less than 5 again. So Asia, where can I put a dot on my y-axis? Yep, at positive 5. Good. So now I have my dots, and I'm going to connect them with my line. Now we just need to decide if it is solid or dotted. So take a look at our inequality symbol here. That's just a regular old less than sign, and there's no bar underneath. What do you think, Aaron? I'm sorry, I couldn't hear you. It is dotted. Yep, there's no line underneath, so we are going to use a dotted line. And yes, Lynn, there will be a video up later. So we are going to put our dotted line going through. And now we need to decide where to shade. So this is a less than. So Alex, do you remember from yesterday, if it's less than, should I shade above or below? Yep. If it's less than, we want to shade below. Good. And something I want to make sure we understand, and we'll talk about this more on Thursday. When you shade something, that's where all of your answers are. So I could pick any point in this purple shaded area, and that's an answer to this inequality. Anything that's not in the shaded part is not an answer. Anything on a dotted line is not an answer. Anything, though, on a solid line is an answer. Okay, so kind of like your open versus your closed circles. Anything on a solid line is an answer. Anything in a shaded part is an answer. But anything on a dotted line or anything in the not shaded part, it won't work. It's not part of the answers. All right, so we just have some more examples on, underneath and then a few on the back. All right, so these ones will also work really well. I think we're actually probably going to do everything with cover up method, even if it doesn't work out great. I think it's probably just the easiest way to do it. So we have 3. Number 3 is 2x minus 3y is greater than 6. So I want to find my x-intercept. Bailey, what should I cover up if I want to find my x-intercept? I can't hear you, Bailey. It looks like you unmuted yourself, but I don't know if your mic's working properly. You can type it in the chat if you want. So the 6 is on the other side. We don't have to worry about that. We want to keep that But if we're going to find our x-intercept, if we want to find our x-intercept, then what we actually do, Bailey, is cover up anything that's attached to the y. So we want to keep that 6 there because it's what our inequality is kind of set equal to in a way. So to find your x-intercept, cover up your y. And now we just have 2x is greater than 6. So then I'm going to write 2x is greater than 6. But at this one, I'm not quite done. I don't quite have my x-intercept yet. Oh, okay, gotcha. Does anyone remember what I would have to do next to work on getting x all by itself? Because it's not quite there. I have 2x is greater than 6. What should I do to keep getting x by itself? Yep, good, Erin. I'm going to divide both sides by 2. And if I divide both sides by 2, that's going to give me x is greater than 3. So now that is my x-intercept. So on my x-axis, I'm going to put a dot at 3. Now I'm going to do the same thing. I'm going to do the same thing with my y's. So who can tell me what I need to cover up with my to find my y-intercept? Yep, I need to cover up the x. Good. I want to look at something real quick. 1 second. I just want to make sure I don't forget about something. All right. All right, so I'm going to cover up the x. So then that's going to leave me with negative 3y is greater than 6. Negative 3y is greater than 6. Who remembers what we need to do in a problem like that? Very good, Erin. Yes, if we are dividing by a negative, we need to make sure we flip our inequality. So we're going to divide both sides by negative 3. Oh, it's glitching out there. I don't know why it won't let me right there. Okay, so we're going to divide both sides by negative 3, and Erin's right. That means we have to flip our inequality symbol, and 6 divided by negative 3 is negative 2. Now that's something that I actually wanted to mention, and I'm glad that Erin mentioned it. I wanted to make sure we, yes. Okay. So I wanted to make sure we didn't forget about this. We had to divide by a negative, which means we had to flip our inequality symbol, right? Now, so we're going to still put our dot at negative 2, but something needs to change here. And we'll probably do the next one in a different strategy so you guys can kind of see. If you guys look at your equation, see how the y has a negative in front of it? So when we moved that over, didn't that flip our inequality symbol? Right, that's what Erin said. So this is actually the new inequality symbol that we want to look at. We want to look at this as a less than because it got flipped around. So first, let's decide what our kind of line is. Let's see, Hayden, do you think I would use a solid or a dotted line here? Well, so we got to, right, because there's no what underneath your symbol. Right, there's no, you need that little line underneath, right? If you see the line, then use a solid line. This time we're going to use dotted, so put your dotted line going through there. And now we need to decide where to shade. So this is the tricky part, and we're going to do, I'm going to show you kind of a different way so it's a little easier to figure this part out. But we actually want to use our new inequality symbol, because didn't we have to flip it around? And we can't just ignore that. We want to use our new inequality symbol. So you got to think of this as a less than. So Kaysen, if it's a less than, do you think I should shade above or below? Any idea, Kaysen, above or below? No. How about Jake Sanders? What do you think? If it's less than, should I shade above or below? So if it's a less than, do I want numbers bigger or smaller? Yeah, we shade below because we want numbers that are smaller because it's a less than. Were you maybe thinking that since it's pointed this way, we kind of like shade that way? That can sometimes get a little tricky. All right, let's take a look then. How many of these do we have? We got a couple more. Okay, good. Because we need a little variety in here. All right, so let's take a look at number 4. So number 4, we're going to do this slightly differently because this is a really easy one to rearrange. So the cover-up method is really nice and it works out really well sometimes, but we also want to know how to rearrange them because sometimes that just works out a little nicer depending on the numbers you're given. So to rearrange this to a y equals mx plus b, we're going to use our 2-column method. And we've done this before, but it's maybe been a minute. So you're going to put your column under your inequality symbol. And remember, you want to turn this into a y and then an mx plus b on the other side. So we only want our y's on the left. We want everybody else on the right. So if we only want our y's on the left, do you guys think that negative 4x should stay or should it go? Yeah, Asia says it should go, and I agree. And when it goes, what does it need to switch to? A positive. Good. So this negative 4x is going to go and become a positive. And we should bring our inequality symbol with us. All right, so we've moved that. Now on to the y. Should the y stay or go? Asia says it should stay. I agree. And now we're on the other side. What about the negative 8? Should the negative 8 stay or go? Asia says stay. Negative 8. So this is our new equation that we're going to look at. And this is a good way to look at it because this is y equals mx plus b form, which we need to be really good at because that's what most of our graphing is in. So we have y is greater than or equal to 4x minus 8. So now this is just like what we did yesterday. Who can tell me what my slope is in this, or not my slope, I'm sorry. Who can tell me what my y-intercept is in this problem? That's what we need to graph first. Asia says negative 8. Do you guys agree? Is the slope negative 8, or is the y-intercept negative 8? Nick agrees. I agree as well. So put a dot at negative 8 on your y-axis. And then we have a slope of 4. Who can remind us how to count out a slope of 4? Asia says 4 over 1. Can someone explain to me what that means? Do we count up? Do we count down? Yep, good, Nick. We're going to count up 4. So 1, 2, 3, 4, and 1 to the right. And then we can do that again. 1, 2, 3, 4, 1 to the right. Because remember, the more points you can have, the more accurate your line's going to be. Now we need to decide if it's solid or dotted. So if we have an or equal to, what do we think? Lynn, if we have the or equal to, if we have that little bar underneath, should we use a solid or a dotted line? Yeah, Lynn says solid line. I agree. The or equal to The little bar underneath means it needs to be a solid line. So draw your solid line going through. Okay. And now we need to decide where to shade. What's this symbol mean? Can someone read it to me? Is this a greater than or a less than? Yep, this is a greater than or equal to. So if it's a greater than or equal to, Mason, do you think I need to shade above or below? Yep, exactly. We would have to shade above. Now again, when your line is has a really like a really steep slope like this, I know it can be a little tricky to think above versus below. So almost think of it as like underneath versus on top of. Okay, underneath would be over here. This would be underneath the hill versus on top of is over here. So if we're above, we need to be on top of our line, which is on this side over here. Okay, so that's how our rearranging works. So I think that will be nice because then you guys can see it again in y equals mx plus b form. Are there any questions on the front before we go to the back? Anyone else? Any questions before we go to the back? Okay. All right, onward. We are now on number 5. We are now on number 5. So here we have 2x plus y is greater than 3. This is not in our y equals mx plus b form, so we're going to fix it. We're going to rearrange this into y. We just want our y on the left, and then everybody else on the right. Okay. So put your bar. So if we want to change this into y equals mx plus b form, we only want y on the left. Olivia, do you think 2x should stay or should it go? What do you think, Olivia? Should 2x stay or should it go? All right. Nick, what do you think? Should 2x stay or should it go? Yeah, it should go. We only want y on the left. So 2x needs to go. And remember, when it goes, we want to switch it to a negative 2x. All right, so we've moved that. Hayden, do you think the y should stay or go? Yeah, it should stay because we want it to be a y and then mx plus b, right? So y is the only thing that should stay on that side. And then, Aaron, do you think the 3 is good where it is, or does it need to move somewhere else? It is good where it is, so put your plus 3. So this is our new inequality here. Y is greater than negative 2x plus 3. So y is greater than negative 2x plus 3. Alex, which number here is my y-intercept? The negative 2 or the 3? Yep, it would be the 3. So we're going to put a dot at 3. And then we got to count out our slope, which is negative 2. Jake Sanders, how would I count out a slope of negative 2? No, negative 2. Yeah, go down 2 and then left or right 1. So if we go down, isn't that the negative direction? You don't want to go negative, negative, right? Because a double negative is going to make a what? Yeah, so we don't want to go down and to the left. We want to go down and to the right. Just because a double negative is going to turn it into a positive. So go down to right 1. And then again down to right 1. All right, we have a greater than symbol. So Jake Newcomb, do you think we would use a solid or a dotted line here? If it's just a greater than symbol with no bar underneath it. All right, nothing. Okay, Asia, thank you. Okay, Corey says dotted. I agree. It is definitely going to be dotted. You have to have the bar underneath it for it to be solid. So this is a dotted line. And then we need to decide if we need to shade above or below. So this is a greater than. Greater than means, Bailey, what do you think? If it's greater than, do we want numbers that are more or less? I couldn't hear you, Bailey. Okay, we want, good. We want values that are more. So Bailey, if we want values that are more, do you think we should shade above or below? Above, good. So we want to shade above here. So remember, treat this kind of like a hill. We need to shade on top of the hill since this is above. Good. All right, let me see where we're at here. I'm gonna, yeah, we need to look at these ones. All right, let's take a look at number 6. All right, so number 6, we got a little bit more going on. There's some extra numbers here, but that is okay. So we are going to put our bar, because we need to rearrange this, into a y and then mx plus b on the left. So, or on the right, I'm sorry. So again, the only thing we want on the left is the y value. That's it. That's all we want there. So 3x. I don't know if Asia's back yet. So Nick, do you think the 3x should stay or go? It should. It needs to get out of here and it needs to become a negative. So we're going to move it over. Okay, Lynn, let me know when you're back. We're going to move it over, make it a negative 3x. It's got to go. So then the 2y, Mason, what do you think? Should the 2y stay or go? You there, Mason? All right, Mason must have stepped away. Corey, what do you think? 2y, stay or go? So for this one, do we want y's on the left or on the right, Corey? Yeah, we want y's on the left. And is the y already on the left? Oh, that's okay. You just saw the 2 part. Yeah, if it was just a regular old 2, then it would need to go. But since it's a 2y, we get to keep it there. And then the 8, the 8's already on the other side, so we're going to leave that where it is as well. All right, so now we got a little issue though. Not a big issue, but a little issue because we're not quite done. Does anyone know why we're not quite done? No, Alex doesn't see it. Does anyone see why we're not quite done? There's something next to that y. Corey, did you have an idea? The 2, that 2 should not be there. The y should be all by itself. Well, doesn't this mean 2 times? So if we're multiplying by 2, we can get rid of it by dividing by 2. But remember, when you multiply or divide, you don't get to pick and choose. If you divide one thing by 2, we have to divide everybody by 2. So what's going to happen is on the left now we just have our y, which is good. Our y is all by itself. And now on the other side, we just need to simplify. Now over here, ladies and gentlemen, is -3 divisible by 2? No, it is not. But can we just leave it as a fraction? Do we have to stress about it? No, just don't stress about it. Just leave it as a fraction. This is -3 over 2x. And that's okay because we can have fraction slopes. And then over here, is 8 divisible by 2? Yes, Corey, what's 8 divided by 2? 4. So then we're going to have plus 4. And here is our new equation. So it was just one little extra step there. All right, so now we need to graph this. I don't know if Lynn is back. Jake, what's my y-intercept here? Jake Sanders, what's my y-intercept? I don't know if Jake's there. Jake, where'd you go? Okay, good, you're still here. Yes, it is 4. Yep, so put a dot at, oh, that's okay. That's okay. So put a dot at 4. And now we need a slope of -3 over 2. Aaron, how do you think you'd count out a slope of -3 over 2? Very good. Down 3. So 1, 2, 3, and 2 to the right. And we can do that again. Down 1, 2, 3, and 2 to the right. And now we need to decide our type of line. So if we're just dealing with a less than, again, there's no bar underneath. So Asia, do you think we would use a solid or a dotted line? Good. We're going to use a dotted line. And now we need to decide where to shade. So again, this is a less than. So if it's less than, Hayden, if it's a less than, do you think I should shade above or below? Below, very good. So I'm going to shade underneath or below my line here. Good. How are we feeling about this so far, guys? Good. Good. Yeah, because really it's almost the exact same as yesterday, just one little step extra with rearranging. We're going to do number 7 together, or actually, wait, we might switch that. Let's do, because they both have negatives. Let's do 7 together, and then I'm going to have you guys try out 8 on your own. I'll give you a couple minutes on it, and then we'll go over it. And I'd like to hear from people and volunteers. Guys, remember, I gotta get feedback from you. I can't look at you and see if you're confused or not. So just make sure we're participating or asking questions if we're confused. So for number 7, we have 3x minus 2y is less than or equal to -4. So this is not in the form we want it. We need to rearrange this into y equals mx plus b. So put your bar. We want our y on the left. Okay, thanks, Lynn. And our mx plus b on the right. So 3x. Olivia, should this 3x stay or go? Yep. Oh, wait, the 3x. So we only want y's on the left. Is the 3x a y term? We only want y's on the left. So if we only want y's, what do we think? Does 3x look the way we need it to? What do you think, Olivia? Does it look like a y term? All right. Nick, what do you think? Should the 3x stay or go? Yeah, why doesn't it belong there, Nick? It's not a y term, it's an x term, so it does not belong on that side. So we're going to move it. Nick, do you remember what happens to it when we move it over? It does become a negative. Very good. We are going to move it. It's going to become a negative 3x. All right, now we're at the negative 2y. Lynn, do you think the negative 2y should stay or go? It is going to stay, yep. So drop down your negative 2y. We don't have to do anything to it yet. And then on the other side, we got a negative 4. So Corey, is the negative 4 good where it is? Yes, it is. It is good where it is. Leave it there. But now we have a similar issue that we did in the one before, where we have a number attached to our y, and we don't want it there. We want y all by itself. So remember, this means negative 2 times y. So how do I get rid of multiplication? We will have to flip it. Very good. And I need to should I add, subtract, multiply, or divide? Very good. We need to divide, and Corey's right. We will have to flip it. Corey, why did you say we're going to have to flip it? Well, when we divide by a what? What kind of a number are we dividing by specifically? A negative. When we divide by a negative, we need to flip our inequality sign. Good, Bailey. Yeah, we need to divide, and we need to flip our inequality sign. So our y is just now a y, and then our less than or equal to needs to flip around, become a greater than or equal to. And now we need to divide here. Is a negative 3 divisible by a negative 2? No. Can't divide 3 by 2. But if you have a negative over a negative, what should you do with that? Very good, Corey. Yeah, we cannot divide it, but we can change it into a positive because double negatives will cancel out. So this is just going to stay 3 over 2x. And then what's negative 4 divided by negative 2? Close. What's a negative divided by a negative, though? Yeah, positive 2. Very good. So positive 2. And that is our new inequality. We got y is greater than or equal to 3x, or 3 over 2x plus 2. So let's see. Alex, what's my y-intercept here? Yep, it would be the 2. So we're going to put a dot at 2. And then Dallas, what's my slope? No, I was asking Dallas, don't worry. So you're right, Alex. The 2 would be your y-intercept, but Dallas, not Alex, Dallas. That's okay. What would be your slope, Dallas? And do you remember how you would count that out? Yep, up 3. So go up 1, 2, 3, and then over to the right 2, and we can do that again. Up 1, 2, 3, to the right 2. And now we need to decide what kind of line we want. Hayden, do you think we should use a solid or a dotted line? Solid. How come you're picking solid, Hayden? Yep, very good. We have the little line underneath. So we want to use a solid line. Ooh, guys, that might be the best line I've drawn today. All right, so now we need to decide where to shade. Now, one of the key things here, guys, is I'm not always going to be there to read your inequality symbol to you, right? You got to recognize it. So can someone tell me what this inequality symbol is? Like how you would read that? Very good. Greater than or equal to. So if it's a greater than or equal to, do I need to shade above or below? Very good, Corey. Yep, greater than means I want numbers that are bigger, so we need to shade above. Very good. I feel like we're doing pretty well with this. I'd like you guys to try out number 8. You are going to have to rearrange it, and you are going to have to flip your sign because you're going to divide by a negative number here. So try it out. Take a minute or two. Try it out. You might not get it all the way done before we need to go over it because I want to give you guys time on your homework. But take a minute or two and try that out, okay? And let me know if you need help with it because obviously I can't walk around and help you. So let me know if you get stuck. How's the rearranging going, guys? Good. Anybody stuck? Any questions yet? Okay. All right. I know we might not totally be done, but I don't want to give you guys so much time where you get maybe a little sidetracked since I'm not there. So let's take a look at number 8. We need to rearrange this, turn this into a y on the left and then an mx plus b on the right. So who wants to help us rearrange it? Who thinks that they got this part right? All right, Asia, help us out. What'd you do? That's okay. Oh, that's okay. So you can just start from what you think you'd do. Okay. And what are we going to do with it when we move it? Very good. Okay, so we're going to move it to the right and change it to a positive. And then what else did you do? Okay, no, I say, well, that's the only thing you had to rearrange, but like, how should I write this line? It's missing a bunch of stuff. Yep, very good. That's exactly what you should get when you rearrange it. The negative 3y would stay, the negative 4x goes and becomes positive, and the positive 6x stays. Very good. All right, who can tell us what they did for the next step? Yeah, very good, Corey. We got to divide everybody by -3. Corey, when you divided by -3, what'd you end up with? Good. Good. Good, good, good. And with the 4 over -3, you can leave it as 4 over -3, or you can throw that negative sign in the front if you want. It does it really matter where a negative is in a fraction, guys? It doesn't make a difference, right? It could be on the top, it could be on the bottom, it could be on the front. It doesn't really make a difference. And then Corey, I heard you say that you wrote it as a plus a -3. That's fine. I would probably change it. Do you really want to have two signs there though? I would probably change it into just a -2. Or I'm sorry, I think I said a plus a -3. You should really just change it to a -2. It's not incorrect. I just worry that you'll graph the wrong number because you'll see the plus, you know? And the negative is the more important, but very good. Yeah, don't forget to flip it. You need to flip the inequality symbol because we had a divided by a negative. So your new equation should have been y is less than -4 x minus 2, or 4 over -3x minus 2. Good. So who can tell me what we need to do now? What's the, very good. Corey, what is my y-intercept? What number? Very good, -2. So put a dot at -2. And then someone else, what do I do after that? Oh, come on, guys. I'm sure somebody knows. Okay, so Asia says I need to find my slope. I trust that Asia knows how to find slope because she's told us already today. So somebody else, how do I then do my slope here? So we can go down, but if you go down, Alex, then you want to go to the right. Because isn't there only because see how there's only one negative sign? So you only want to go in the negative direction once. So we can either go up and left, because up is positive, left is negative, right? Or we can go down and right. It's up to you which one you want to do. But if you go down and left, that's negative, negative. So either way, yeah, you could either gone down, so down 1, 2, 3, 4, and to the right 1, 2, 3, or you could have gone up 1, 2, 3, 4, and then left 1, 2, 3. Either way, but good, yeah. Mm-hmm. Yeah, no, either way is fine, Corey. So yeah, if you have, because yeah, I know that you had it like this, right? 4 over -3. So if you have it like that, Corey, then you can totally go up and to the left, because that means the same thing as down and to the right. Does that make sense? Okay, yeah. So if you went up and to the left, that's totally fine. That is perfectly correct. And now we got to decide our sign. So somebody else, somebody who hasn't participated yet for this problem, what kind of line do I need to use? And how do you know that's what you got to use? Oh, come on, guys. I know that we know what line to use, or we should be able to figure it out. Well, so I more mean like dotted or solid. Yeah, dotted. I don't know who said that, but someone said dotted. Does that make sense, Alex? Oh, yeah, no. So we want dotted or solid. Who said dotted? No one's gonna. Oh, it's Dallas. Okay. All right. So yeah, we are absolutely correct, Dallas. We need a dotted line here. How can you tell it's dotted, Dallas? Yeah, you don't have the little bar underneath. Very good. And now we need to decide if we're going to shade above or below. So then somebody else, so not Corey, Asia, Dallas, or Alex. Where do I need to shade, and how do you know that's where you need to shade? I don't think so. I've heard from some other people. Nick, what do you think? Do you think I need to shade above or below? You do, because this is a less than, right? So yeah, good. See, we know. I think we're just being shy. So good. Yeah, shade below. Very good. Do we feel okay about this, guys?